start. Okay, so I should start sharing the study material or the material that I today will discuss. Today.
Ma'am, you are not audible.
I am not talking. Now tell me if the screen is visible or not. Is the screen visible?
Visible, ma'am.
Yes, ma'am, it is visible.
Okay. And can you hear me? Can you hear me? Someone told
Yes,
me
ma'am.
that. Okay. So I think no problem from my end regarding network. If any problem occurs, then please let me know. Okay. If there anyone
Ma'am, some
having-
background noise is coming from your mic.
try to manage it, just hold for 1 minute. Hello, now is this okay? Hello.
Yeah, ma'am.
Okay. So in the last class, if anyone is waiting for joining, then please let me know, because when I'm sharing the screen, I cannot see every time if anyone is waiting. Okay, 13 people were waiting. Well, so in asymptotic notation, as we discussed, we take help of the asymptotic notation, that is a functional representation and part of mathematics, to represent the complexity of an algorithm. That complexity may be time complexity or space complexity. So to represent that complexity, we take help of asymptotic notation, right? And these are a kind of a function. Okay. So in the last class, I discussed this topic using some graphical representation. Right. So today I will use some example to explain it. Okay. So let's see some classes or some representation of a function. Yes.
Hello.
Hello. Hello.
Ma'am, someone is joining, please. Hello. Ma'am, someone is joining. Please admit it.
I'm editing. Okay. So as I'm saying that we represent the time complexity using some function, right? Using some function. So how much time will require to run a function or run an algorithm? We represent that thing using a function. Okay. What will be the parameter of the function? So in the parameter of the function, we use number of input as a parameter, number of input as a parameter, right? And that thing represented by n. In algorithm or data structure, we use n, this particular thing, as the number of input, right? Or input size. Along with some constants are used to construct the function, which will represent the total complexity. Fine, that's all. Now, suppose, okay, so if n is,
अरे हाँ ऐसा दे दे हाँ मिला बड़ा के बेटा बड़ा खा
if n is the number of input, then we could represent the complexity in so many classes or so many terminologies. Okay, so I have written some classes over here. The time complexity may be 1, maybe log of n, maybe root of n, maybe n log n, maybe n square, maybe n cube, or something n to the power 4, n to the power 5, and so on, or maybe 2 to the power n, or maybe 3 to the power n, or maybe n to the power n, or multiple, or maybe multiple of this term, any of this term. So this many variation may occur to represent the time complexity or space complexity. So in general, I am telling that complexity, right? Now, these classes or these functions are, you can see, represented in increasing order, right? 1 is less than log of n, less than root of n, less than n, less than n log n, less than n square, less than n cube, and so on. So these are represented in increasing order. So this many representation, this many variation may occur to represent the complexity, right? Now, what we will do, we take some help of some symbol or asymptotic notation or some notation to represent the complexity, as I told you. Okay, so what are the symbols? One is big O, one is big omega, another is theta. So big O is represented by capital O, big omega is represented by capital omega, and theta, the symbol of theta, you know, we write this way, theta. Okay, so big O represent the upper bound of a function. That means how maximum a function could take a value, how maximum value, what maximally one function could be represented. And big omega, how much minimally it could be represented. And theta, that means average bound, not the maximum, not the minimum, just middle point, just exact value is represented as a theta bound or type bound. Okay, just keep this three things in mind. If I want to represent a function using its upper bound, then we will take the help of big O. If I want to represent the lower bound of a function, then we take the help of big omega. And if I want to represent a function exactly that with the exact value, then we take the help of theta. Whereas theta is the most precisely way of representing a function. However, in general, it sounds good that not maximum, not minimum, and the exact value we are going to represent. But what happens in the present scenario, that it is not always possible to represent a function with its exact value. In that case, we take the help of big O notation or big omega notation. In the maximum cases, we use the take the help of big O notation, because if any function is represented by its upper bound, then maximum cost we can assume, or maximum cost we can figure out. Then the complexity is represented, which is maximum bound. So one thing could be assured, that anything could, the complexity cannot be more than that. So this is a confirmation that the complexity cannot be more than that. So that in maximum cases, we use the upper bound of a function to represent the complexity. However, the best thing is to represent the complexity using the theta bound. Okay.
Excuse me. Hello.
Hello. Yes, please.
Yeah, ma'am, someone is trying to join in 5 minutes. Please admit it.
Okay. Now this is all. This is about the concept of big O, big omega, and theta. Now, if I want to represent or want to discuss this thing using some example, then what happens? So first of all, I am discussing big O notation. Okay, yeah, this is ON. It looks like ON, but it is OH. Okay, just consider it as OH, as I written. Yes, big O in capital O. And sometimes it is also called order of. So if I mention order of, then you should understand that I'm telling about big O notation. Order of something, that means I am using big O, right? Now, the definition is something like that. Fn equals to it is written Fn equals to order of or capital O or big O of Gn. So Gn is a function, Fn another function. So I am representing Gn using order of something using the symbol to represent Fn. So Fn equals to order of Gn. Fn is a function, Gn is a function. If I fulfill some condition, then if I fulfill some condition written here, for that we can write this representation Fn equal to order of Gn, for which there are some conditions. So what are the conditions? Let's say, let's look into that. If and only if IFF means, the meaning of IFF is if and only if, and this symbol means there exists. If there exists positive constant C and N0, so we need some positive constant C and N0 such that if less equals to C into Gn, C into Gn, Fn equal less than equals to, if this scenario occur, Fn less than equals to C into Gn for all n greater than N0, then we could say Fn equals to order of Gn. So this is the definition. Now let's take the example. Say Fn, I am assuming a function, a simple function, first order function, that is Fn equals to 2n plus 3. This is a simple function. Okay, so with n there is associated constant term is 2 plus 3. This is another associated constant term. So now 2n plus 3 is our Fn, right? We can write 2n plus 3 less than equals to something. So what we could write here? We could write 10n, we could write 5n also, we could write 7n also. Suppose I am writing 10 into n. So 2n plus 3 is less than equals to 10 into n, right? Always less than equals to 10 into n for all n greater than equals to 1. If I take value of n equals to 0, then it becomes 3. Left hand side becomes 3 and right hand side becomes 0. So for n equals to 0, it is not true. But when n equals to greater than equals to 1, then it is true. So suppose I am taking the value of n equals to 1, then left hand side becomes 2 plus 3 is 5 and the right hand side becomes 10 into 1 is 10. So 5 definitely less than 10. It's true, right? If I take value of n equals to 2, what will happen? 2 into 2 is 4. 4 plus 3 is 7. 7 less than what? If here n is 2, then 10 into 2 is 20. So 7 less than equals to 20. Getting my point? So definitely this function is less than 10n. So if I, instead of using 10n, if I use just 5n, you also can find out that if I use instead of 5 instead of 10, then also it will work. Like 2n plus 3 always less than equals to 5n for all n greater than equals to 1. If I use here 4n, then also it will work. If I use here 6n, it will work. If I use here 7n, it will work. Anything, any that means from 4 to any real number, any whole number, if I consider as the term instead of 10, it will work, right? So now what is happening here? If I say f2n plus 3 is our fn, which is less than equal to 10 into n, well, 10 is the constant term, so I am representing 10 as c, so 10 is c here and n is gn. So if gn equals to n and if c equals to 10, then always fn less than equals to, always less than equals to c into gn. What is written here? Fn less than equals to c into gn for all n greater than equals to n0, where n0 is what? N0 is some term. Okay. So it is 1 here. So n equals greater than equals to 1, and c may be 10, maybe 5, maybe 6, maybe 4. So for here I am taking c equals to 10. So for these two terms, for these two specified terms, our fn equals fn always less than equals to c of gn, c into gn, so that we could write following this definition that fn equals to order of gn. So meaning of this definition is elaborately discussed here. Right? So fn equals to order of n. Clear? Any doubt? कोई भी फंक्शन को कोई दूसरा फंक्शन का कोई दूसरा फंक्शन के साथ एसोसिएटेड और मल्टीप्लाइड कांस्टेंट टर्म से अगर मैं छोटा प्रूफ कर दूं तो मैं लिख सकती हूँ वो फंक्शन वो दूसरा फंक्शन से ऑलवेज लेस है. दैट मींस द फंक्शन इज ऑर्डर ऑफ द सेकंड फंक्शन. दैट मींस fn equals to order of n. Is there any doubt? Is there any question? Please let me know, because I will skip and I will move to the next. Now,
मैम फिर से समझाइएगा.
बीगो नोटेशन से मैं कोई फंक्शन को कब रिप्रेजेंट कर सकती हूँ, राइट? तो यहाँ पे एक चीज बोला क्या है, fn एक फंक्शन है, gn दूसरा फंक्शन है. fn is a function, gn another function. So when I write fn equals to order of gn, fn equals to order of gn कब लिख सकते हैं? जब ये जो मतलब क्वेश्चन है, ये जो माउस पॉइंटर मैं दिखा रही हूँ वो आप लोगों को दिख रहा है. जब ये कंडीशन सेटिस्फाइड हो, कौन सा कंडीशन? fn less than equals to c into gn for all n greater than equals to n0, right? तो ये कंडीशन सेटिस्फाई होने से मैं लिख सकती हूँ fn equals to order of gn. जैसे कि यहाँ पे एक एग्जांपल हम ले लेते हैं. fn करके एक फंक्शन है, जो फंक्शन में क्या रिप्रेजेंट करता है? यह फंक्शन रिप्रेजेंट करता है 2n plus 3. fn equals to 2n plus 3, राइट? अब 2n plus 3 किससे छोटा है? 2n plus 3 किससे छोटा है? तो मैं यहाँ पे एक आर्बिट्ररी वैल्यू ले रही हूँ, 10 into n. 10 into n से ये छोटा है. तो मुझे ऐसा एक टर्म लेना है जिसके साथ प्लस या प्लस या 2 3 4 5 टर्म नहीं रहेगा, एक ही टर्म रहेगा. तो मैं एक वेरिएबल वाला टर्म अगर लेना चाहती हूँ तो मैं लिखूंगी n. तो n के साथ कितना मल्टीप्लाई करने से ये 2n plus 3 ऑलवेज छोटा होगा. तो n के साथ मैं 10 मल्टीप्लाई करती हूँ. देखो, तो n के साथ मैं अगर 10 मल्टीप्लाई करती हूँ तो 2n plus 3 ऑलवेज छोटा होगा. तब जब n का वैल्यू n से 1 से ग्रेटर होगा, राइट? n का वैल्यू 1 से ग्रेटर है. If that is so, then 2n plus 3 equals to fn. 2n plus 3 क्या है? fn है. और 10 into n, 10 क्या है? कांस्टेंट टर्म. सो मैं यहाँ पे लिख रही हूँ c, और यहाँ पे n equals to gn. तो n को मैं बोल रही हूँ gn equals to n और n equals to gn. तो मैं अभी क्या लिख सकती हूँ? fn equals to और fn less than equals to 10n, fn less than equals to 10n, then fn equals to or fn less than equals to c into gn, where c is n and gn equals to n. This condition is satisfied. If c equals to 10 and if gn equals to n, in that case fn is always less than c of c into gn, right? If that is so, we can write fn equals to order of gn. समझ में आया या फिर से समझाऊं? Any doubt?
मैम इसके बाद ई है या क्या पढ़ेंगे उसको?
IFF, if इसको if ही पढ़ना है, और यह इसको ये जो साइन है उल्टा करके ई लिखा हुआ, इसको देयर एग्जिस्ट बोला जाता है. These are mathematical terms, and I expect you should have this prior knowledge because you are studying mathematics also, right? तो अगर नहीं पता है फिर भी मैं बोल देती हूँ, ये इसको बोला जाता है देयर एग्जिस्ट, देयर एग्जिस्ट। आइदर यू कैन राइट दिस और यू कुड राइट देयर एग्जिस्ट। और यहाँ पे प्लस भी कांस्टेंट का मतलब पॉजिटिव कांस्टेंट, दिस मीनिंग ऑफ दिस इज पॉजिटिव कांस्टेंट। ठीक है, और कुछ? हाँ
मैम ये फंक्शन में तो हम लोग पता कर लेंगे कि ये फंक्शन अगर ये fn इक्वल टू सी इंटू gn को अगर सेटिस्फाई करेगा तो मेरा ये फंक्शन होगा मेरा बिग ओ एफ बिग ऑफ एन। पर अगर एल्गोरिदम मैम दिया रहेगा तो उसमें हम लोग कैसे पता चलेगा कि इसका टाइम
वो डेफिनेटली एल्गोरिदम आप जब भी पढ़ोगे, एल्गोरिदम जब भी पढ़ोगे उसका एक एनालिसिस पार्ट रहेगा, जैसे कि सर भी कराएंगे, मैं भी कराऊंगी। तो उसका ये फंक्शन और रिप्रेजेंटेशन क्या हो सकता है या कॉम्प्लेक्सिटी कैसे एनालाइज किया जा सकता है, वो उसी टाइम डिस्कशन हो जाएगा। ठीक है, ये फंक्शन डिटरमाइन करना थोड़ा वहाँ पे मुश्किल होगा, लेकिन वहाँ पे एक लाइन कितनी बार रन कर रहा है इसके ऊपर डिपेंड करके मैं ये एक अंदाजा लगा सकती हूँ कि इसका कॉम्प्लेक्सिटी कितना होने वाला है। राइट? Okay, so when we will discuss that, it will be clear gradually. Okay. Now for this, I have used this example to make the concept clear. Just only this thing. Okay. तो यहाँ का कॉन्सेप्ट अगर क्लियर नहीं होता है तो मुझे बताओ, एल्गोरिदम के साथ कैसे रिलेट करना है। जब हम लोग कोई एल्गोरिदम पढ़ेंगे तब हम लोग इसके बारे में डिस्कस करेंगे। राइट? The order of something means we are maximum, we are representing the complexity in the maximum form or using the upper bound. तो उसके अपर बाउंड मतलब क्या? बहुत सारा कांस्टेंट टर्म वहां पे रह सकता है, जिसको हम लोग बेसिकली इग्नोर करते हैं। जैसे हम यहाँ पे लिख रहे हैं fn इक्वल टू ऑर्डर ऑफ n, तो ऑर्डर n मतलब हमको यहाँ पे एक चीज पता चलता है कि n का जो पावर है वो है 1, n टू द पावर 1 इज हियर। तो इसके साथ एसोसिएटेड कोई कांस्टेंट टर्म रह सकता है या तो है, जिसको हम इग्नोर कर रहे हैं और सिर्फ हम लोग लिख रहे हैं fn इक्वल टू ऑर्डर ऑफ n। राइट? ओके। और एक फंक्शन अगर मैं यहाँ पे कंसीडर करूंगी, मैं प्रिंट ओपन करती हूँ। सपोज मैं लिख रही हूँ fn इक्वल्स टू fn इक्वल्स टू सपोज 5n स्क्वायर प्लस n प्लस 2, ऐसा अगर मैं लिखती हूँ तो ये जो फंक्शन है ये किससे बड़ा हो सकता है। तो मैं इधर मैं लिख रही हूँ 5n स्क्वायर प्लस 2, सॉरी प्लस ये होगा n प्लस 2 which will be less than equal to what? Something n square. If this is 5 and if I write 6 here, then let's see what will happen. If n equals to 0, then the left hand side is 2 and right hand side is 0. So 0 will not occur. 0 will not work. If I take n equals to 1, what will happen? यहाँ पे रहेगा 5 प्लस n, n का वैल्यू क्या होगा 1, so 5 plus 1 plus 2, that means 8 and 6, यहाँ पे क्या होगा right hand side में 6 into n is 1, 6 into n where n is 1, so the value is 6. So here 8 is not less than equals to 6. So we cannot take value of n equals to 1. Then we have to take value of n equals to 2. Then what will happen? Let's see. N square 4, that means 5 into 4 plus 2 plus 2 plus 2. what is 20 24 ये मिल रहा है हमें 24 और यहाँ पे मुझे क्या मिल रहा है 6 into 4 that means 24 so definitely 24 is less than equals to 24 so when n value of n is 2 then this inequality okay so it is running out of time within 10 minutes the meeting will be closed after that you should rejoin the meeting right everyone
Okay,
should rejoin the meeting and before closing this first meeting all of you should write your roll number in the chat box okay so if I take n equals to 3 then definitely this function that means 5 into 9 plus 3 plus 2 less than equals to 6 into 9 okay definitely this is working so value of n0 is what value of n0 is 2 okay because it is written here you can see it is written here for all n greater than equals to n0 so n0 is what n0 over here is 2 the minimal value for which inequality will be satisfied so fn equals to 5n square plus n plus 2 and what is gn here gn equals to n square gn equals to n square and what is c1 or c that means the constant term so we are taking the constant term c for which the inequality is satisfied so c equals to 6 here right so that we could write fn equals to order of square where c equals to 6 and n greater than equals to n0 n greater than equals to n0 whereas n0 equals to 2 right n0 equals to 2 so or we could write n greater for all n greater than n0 equals to 2 in that way also we could write so for this constant value and for this n0 or value which is 2 this inequality is satisfied which is fn equals to c fn less than equals to c into gn okay so here I could write fn less than equals to c into gn where c equals to this 6 and gn equals to what n square right so this is the total concept about the big O notation or big O asymptotic notation okay if I observe the time complexity thing in graphical representation of time complexity so it is saying that big O notation which is big O notation represents the upper bound of the running time of an algorithm thus it gives the worst case complexity of an algorithm so basically you should not follow the case thing worst case best case these are the other thing don't mess up any best case to worst case thing with this notation thing okay it is just a representation using the upper bound of any function let's see the diagram so as I said if I want to map this function with this diagram so what it is saying So after n0 for this function fn, suppose this is fn, and what is gn? Gn is here n square. So and what is c? C is our 6, right? C is our 6. Gn equals to n square. So fn means 5n square plus n plus 2 always less than 6n square after the value n0 equals to 2. After the value n0 equals to 2. So after this, you can see Cgn always dominating fn as the value of n is increasing. Okay. If that is so, then we can represent the time complexity as fn equal to order of gn. So this is the meaning of this diagram. Fine. Any confusion? Any questions? Okay. Next. Okay. So this is all about big O notation. So what it is representing, let's say. So closure's upper bound is n here, because we can represent the upper bound for this example, fn equal to 2n plus 3, we can represent it as order of n. So if upper
Hello?
bound, yes.
मैम
हाँ?
मैम एक एग्जिट में उसको लॉगिन कीजिए, अंदर कीजिए ना उसको, बाहर में उसका नेटवर्क प्रॉब्लम से वो लीव कर गई थी।
यहाँ पे तो नहीं दिखा रहा है।
मैम अनुष्का कुमारी से होगा।
Her request is not reached. It's not showing anything, any pending. Okay. I cannot see anyone waiting.
मैम हो गई बोलो।
Okay, okay. Okay, if anyone left
Thank
who
you,
has
ma'am.
not written their roll number in the chat box, please write their roll number in the chat box, right? Immediately, because within 3 minutes, this first meeting is going to complete.
मैम हेलो
Yes, yes.
मैम एक बार ग्राफ फिर से एक्सप्लेन करिएगा।
This is our graph, right? Okay, this is going to close it into 2 minutes. Okay. So as per our function, what I have taken as example, our function is fn equals to 2n plus 3, right? Fn equals to 2n plus 3. So suppose this is the function fn equals to 2n plus 3. And what is our gn? As we tried to find out, the gn equals to n, right? For gn equals to n, this inequality is getting satisfied. So gn equals to n, and using the value of constant equals to 10, we are finding out that this inequality or this inequality is getting satisfied. Fn less than equals to c into gn, where c equals to 10 and gn equals to n, where fn equals to 2n plus 3. So 10 into n is always greater than 2n plus 3. Okay. If fn equals to 2n plus 3, then gn is what? N, and c equals to 10. So 2n plus 3, which is fn, always less than 10 into n, which is c of gn or c into gn. That means cgn is always dominating fn. Okay, what is the upper bound of fn? Upper bound of fn is c into gn, and that upper bound is satisfied after this n0 term, n0 value. What is n0 value? N0 value is 1. N0 value is here 1. Yes, where for all n greater than 1. For all n greater than 1. So if n is equals to 0, then this inequality does not satisfy. That's why we cannot say what will happen before this n0, this part. Before this n0, you can see Cn is greater, someone you can see Gn is greater. Somewhere you can say Cn is greater, somewhere you can see Gn is greater. So there is no specification which will satisfy the inequality. But after the value n0